In this section of Sustainable Urban Freight course, we will discuss modeling and key performance indicators for the evaluation of various city logistics initiatives. As we learned in previous video that the private cost and public cost such as environment and safety can be used to evaluate a city logistics scheme. Most of the city logistics schemes require a significant change in the current system, which often require a large investment as well. Therefore, in the systems approach to city logistics, models are used to evaluate impacts of the city logistics measures before their implementation. These impact models are related with the choice of the evaluation criteria. As models represent an abstract of the reality, their choice and details are therefore depending on the scope of the scheme, required precision level, and the availability of the data source. For example, it is important to know whether the scheme covers a region or just the CBD. Do we need exact estimation of the evaluation criteria or approximate values are acceptable? And how much data and time is available to model a real-life situation? In another example, if it is required to calculate the routing cost in order to evaluate the economic impact, there can be many modeling choices, such as traveling salesman's problem or a vehicle routing problem with time windows. As we noticed, the details and precision of the evaluation can be enhanced, but it will require more data and more computation time in principle, as the complexity of the model is increasing. Another level of complexity can be introduced if the Euclidean distances are replaced with more precise distance or travel time to be evaluated based on real-life network using a shortest path algorithm such as Dijkstra algorithm. In this case, whether the travel time on the road network links has a fixed average value or if different values have been considered in different parts of the day may further increase the precision level. Similarly, considering a probability distribution of the travel time or even unpredictable changes such as if an incident happens may make our cost model more realistic with increasing data and computation requirements. Clearly, one would most restrict these precision levels for schemes covering smaller areas such as in the central business district. The routing cost model is a very important tool as it is often used to evaluate impacts of many other city logistics schemes. Therefore, let's discuss a little bit more about it. It is based on two basic assumptions. First, in city logistics, trucks deliver goods to many customers in a single route, where the waiting order determines the travel cost. Secondly, it is possible to reduce the number of vehicles such as they are operated by a single company. In simple words, the objectives of the VRPTW model is to find a set of minimum cost routes that serve demand of all customers while respecting the imposed constraints such as capacity and time windows. There is sum of customers' demand on each route must be less than the truck capacity and the truck visit them within their preferred time windows. As discussed few slides back, many different variants of VRP can be considered based on the use of different travel time values. There are numerous other variations. For example, if there exist multiple depots, heterogeneous vehicles, whether the customer's deliveries can be split or not, and so on. If you are interested in this area, you can find many online resources by searching VRPTW on internet. Simple environmental impacts models use outcome of the economic impact models showing the freight activity in terms of length and speed. Recently, some environment and social impacts are also integrated in this economic impact model. For example, considering multiple objectives in VRPTW model, including the emissions, safety and equity issues along with the cost, and other vehicles, for example, electric vehicles and hybrid vehicles. Even with the advanced VRP models, it is not always feasible to understand that how different stakeholders with their diverse objectives would react to a city logistics measure. Therefore, for a simultaneous evaluation, considering multiple stakeholders, multi-agent simulations are often used. The agents learn and base their decision on the information received from the environment, whereas their action in turn modify the environment itself. An iterative simulation of the interactions of these agents among them and with the environment can yield an overall evaluation of a policy. This slide shows an example of interaction between various stakeholders which may result in a distance-based freight road pricing scheme. One can see that various stakeholders are looking to achieve their own objectives, but they have to work in an environment which is created by the decision of the other stakeholders as well. The outcome of the multi-agent models can be used for providing the basic information on the effects of implementing policy measures in the multi-stakeholders meetings, such as in public-private partnership frameworks. In summary, modeling is an important tool used to evaluate the impact of a city logistics scheme before its implementation. Modeling choices and details depend on the scope of the scheme, required precision level, and the availability of the resources. The results can be used to develop awareness and consensus among the stakeholders for the successful future implementation.